All right, let's dive in. Today, we're going to talk about one of the most serious, but also one of the most invisible threats our oceans are facing, acidification. We're going to break down exactly what's happening, chemically and biologically, to see how this is affecting some of the most beautiful ecosystems on Earth, our coral reefs. You know the image, right? When you picture a coral reef, you see this incredible underwater city. It's just an explosion of color and life, these wild, complex structures buzzing with fish and creatures of all kinds. It's this beautiful, thriving world built by tiny animals that supports a full quarter of all life in the sea.
But here's the thing. That vibrant city is in real trouble. It's starting to crumble, and not from something you can see, not from some big, obvious force. No, this is an invisible threat, a quiet change in the very chemistry of the water that's threatening to dissolve the whole thing from the inside out.
So to really understand this crisis, we've got to start with the basics. We have to understand how these amazing structures even get built in the first place. So let's meet the tiny, and I mean tiny, architects behind these massive underwater cities.
This is it. This is our master builder, the coral polyp. It looks pretty simple, right? Just a little soft-bodied creature. But when you get millions and then billions of them together, they pull off an architectural miracle. Each one builds a little limestone cup to live in. And over thousands of years, all those tiny skeletons fuse together to create the gigantic, complex reefs we see today. But here's the secret. The polyp doesn't do it alone. It's got a roommate, a crucial partner living right inside its own tissues, this microscopic algae. You can think of this algae as a tiny, live-in, solar-powered chef. It soaks up sunlight, does its photosynthesis thing, and churns out food for the coral. In return, the coral gives it a safe place to live. It's a perfect partnership. And without it, the whole system collapses.
Okay, so we've met the builders. Now let's bring in the prime suspect in our case of the crumbling reef, and its name is ocean acidification. So it all starts up here, in the air. You see, the ocean is basically our planet's best friend when it comes to climate change. It acts like a giant sponge, soaking up about a quarter of all the carbon dioxide we pump out from burning fossil fuels. Now, that's great for us. It slows down climate change on land. But all that CO2 doesn't just vanish. And there's a huge price to pay for the ocean itself.
And here's what that price looks like in chemical terms. Since the Industrial Revolution started, the ocean's average pH has dropped from about 8.2 down to 8.1. Now, I know you're thinking, that doesn't sound like a big deal at all, right? But the pH scale is logarithmic. What that means is that tiny little drop represents a massive shift in the ocean's chemistry.
In fact, that 0.1 drop means the ocean today is about 30% more acidic than it was just a couple of hundred years ago. That is a faster change in ocean chemistry than anything we've seen in millions of years. And the life in the ocean, well, it just hasn't had any time to catch up.
So, how does being more acidic actually hurt the corals? Well, the best way to think about it is like a grand chemical heist. It's a process that is literally stealing the building materials that corals need to build their homes. Here's the play-by-play of the heist. The CO2 dissolves in the water and forms a weak acid. This acid then releases hydrogen ions that are like super grabby. They immediately hunt down and bond with carbonate ions, locking them up so that nobody else can use them.
And why is that such a big deal? Well, because those carbonate ions are the absolute essential building blocks. They are the bricks that coral polyps need to build their skeletons. So if there are fewer bricks lying around, it becomes much, much harder to build a house. And you can really see the difference it makes. In a healthy ocean full of carbonate, it's easy for corals to build strong, solid skeletons. The reef grows, it's healthy. But in an acidified ocean, it's a constant struggle. Building their skeletons takes way more energy. The structures they do build are weaker, more brittle, and they grow much slower. Sometimes the water is so corrosive that existing reefs can actually start to dissolve. But as if all of that wasn't bad enough, acidification isn't the only problem. It's part of a bigger assault. Our corals are basically being attacked on two fronts, and the whole system is being pushed right to its breaking point. The other major threat is something called coral bleaching. This one is caused by rising ocean temperatures. When the water gets too hot for too long, the coral gets stressed out and literally kicks out its little algae roommate. And since the algae gives the coral its color, all that's left is the transparent polyp and its white skeleton underneath. The corals isn't dead, not yet, but it's just lost its main food supply, and it's basically starving. So now you have this absolutely devastating 1-2 punch. First, the rising temperatures cause bleaching, which is starving the coral. And at the exact same time, the acidification is making it harder for that same starving coral to build or even repair its own skeleton. You throw pollution into the mix, and you're pushing this entire ecosystem right over the edge.
Okay, so this is all happening to a tiny animal, thousands of miles away, for many of us. So why does its fate matter to every single one of us, no matter where we live? Well, the global consequences are frankly staggering.
Just look at this. It's an incredible statistic. Coral reefs cover less than 1% of the entire ocean floor. Less than 1%, yet they support about 25% of all known life in the sea. They are, without a doubt, the biodiversity hotspots of the ocean.
So, when we lose reefs, we lose so much more than pretty corals. We lose the nurseries and habitats for countless fish that support fisheries that feed millions of people. We lose billions of dollars in tourism, and we lose these incredible natural seawalls that protect our coastlines from storms and erosion.
And the damage doesn't stop there. This whole chemical change also harms other creatures that build shells, things like plankton and mollusks, which are right at the very bottom of the food web. So the damage just cascades all the way up, threatening entire ocean ecosystems and the fish we all depend on.
So when you step back and look at the big picture, the ocean has been absorbing our carbon pollution for decades, protecting the climate on land, but at a huge cost to itself. It's created this silent crisis that's unraveling one of the most important ecosystems on the entire planet. And that leaves us with a really big and really urgent final question. The ocean has always protected us. Who is going to protect the ocean?